So as researchers, something we often do is use immense resources to achieve certain capabilities or achieve certain goals. And this is essential to the progress of science or exploration of what is possible. But it sort of creates this unfortunate situation where a tiny, tiny fraction of the world can actually participate in this exploration or can benefit from that technology. And something that motivates me and what gets me really excited about my research is when I see simple opportunities to drastically change that distribution and make the technology accessible to a much wider percentage of the population. And I'm going to show you two videos that have gotten a lot of attention recently that I think embody this philosophy. And they actually use the Nintendo Wii remote. Now, for those of you who aren't familiar with this device, it's a $40 video game controller. And it's mostly advertised for its motion sensing capability, so you can swing a tennis racket or hit a baseball bat. But what actually interests me a lot more is the fact that in the tip of each controller is a relatively high-performing infrared camera. And I'm going to show you two demos of why this is useful. So here I have my computer set up with a projector, and I have a Wii remote sitting on top of it. And if, for example, if you're in a school that doesn't have a lot of money, which is probably a lot of schools, or if you're in an office environment and you want an interactive whiteboard, normally these cost about $2,000 to $3,000. So what I'm going to show you how to do it is how to create one with a Wii remote. Now, this requires another piece of hardware, which is this infrared pen. You can probably make this yourself for about $5 with a quick trip to Radio Shack. It's essentially got a battery, a button, and an infrared LED, and it turns on. You guys can't see it, but it turns on whenever I push the button. Now, what this means is that if I run this piece of software, I can now register, the camera sees the infrared dot, and I can register the location of the camera pixels to the projector pixels, and now this is an interactive whiteboard surface. So for about $50 of hardware, you can have your own whiteboard. This is Adobe Photoshop. Thank you. Now, the software for this I've actually put on my website and have let people download it for free. In the 3 months that this project has been public, it's been downloaded over 500,000 times. So teachers and students all around the world are already using this. I want to quickly say that although it does do it for $50, there are some limitations of this approach, but you get about 80% of the way there for about 1% of the cost. Another nice thing is that a camera can see multiple dots, so this is actually a multi-touch interactive whiteboard system as well. For the second demo, I have this Wii remote that's actually next to the TV, so it's pointing away from the display rather than pointing at the display. And why this is interesting, here they are, is that if you put on, say, a pair of safety glasses that have two infrared dots in them, what these two dots are essentially going to give you is give the computer an approximation of your head location. And why this is interesting is I have this little application running on the computer monitor, which has a 3D room with some targets floating in it. And you can see that it looks like a 3D room. If you can see, like a video game, it sort of looks 3D, but for the most part, the image looks pretty flat and bound to the surface of the screen. But if we turn on head tracking, the computer can change the image that's on the screen and make it respond to the head movement. So let's switch back to that. So this has actually been a little bit startling to the game development community. Because this is about $10 of additional hardware if you already have a Nintendo Wii. So I'm looking forward to seeing some games with it. And actually, Lewis Castle, sitting down there, last week announced that Electronic Arts, one of the largest game publishers, is releasing a game in May that has a little Easter egg feature for supporting this type of head tracking. So in less than 5 months, it went from a prototype in my lab to a major commercial product. Thank you. But actually, to me, what's almost more interesting than either of these two projects is how people actually found out about them. YouTube has really change the way or change the speed in which a single individual can actually spread an idea around the world. I'm just a researcher in my lab with a video camera, and within the first week, 1 million people had seen this work. And literally within days, engineers, teachers, and students from around the world were already posting their own YouTube videos of them using my system or derivatives of this work. So I hope to see more of that in the future, and hope online video distribution to be embraced by the research community. So thank you very much.